Alright, so we're getting started on this warm-up on inscribed angles. We learned yesterday that the inscribed angle, so in this case, angle ABC, is always half of the intercepted arc. So in this case, it would be arc AC. So again, here is our angle, and this is the intercepted arc. Now the only issue here is that we don't know what arc AC is, but we're going to find it. What we do know is that arc AB is 130 degrees, arc BC is 120, and then all the way around should be 360 degrees. So what we're going to do is we're going to add 130 plus 120, and we'll get 250. And then we're going to take our 250, and we're going to subtract it from 360. 360 minus 250 will give you 110 degrees. And so, to solve for AC, angle B, we're going to say that angle B is 1/2 of 110. 110. And half of 110 is 55. Angle B is 55 degrees. Then let's move on to the next problem. Notice here we have a triangle inscribed in a circle. Something else you need to notice about this triangle is that it's an isosceles triangle. So this inscribed angle needs to be congruent to that inscribed angle because isosceles triangles have two congruent base angles. So if this angle that's given to us is 80 degrees, and we know that the three angles in a triangle add up to 180, well, we can do 180 minus 80, and we'll get 100. But that doesn't represent this angle or that angle. It represents them combined. So to get both of those angles, we needed to divide 100 evenly. And so this angle is 50, this angle is 50. But we're asked to find the arc values. So how do I use the theorem yesterday to find the arc values? We have to work backwards. So our angle is still half of the arc. And so in this case, 80 is half of its intercepted arc is x. And so if I want to solve for x, I can divide by 1/2 or just multiply both sides by 2. If we multiply both sides by 2, here the 2 cancels out with the fraction. It's gone. And 2 times 80 is 160 equals x. Or another way to think of this is 80 is half of what number? 80 is half of 160. So x is 160 degrees. We got to figure out what is y. And I want you to understand that once we figure out y is going to be congruent to z because their inscribed angles are congruent. So angle is half of the arc. So in this case, 50 is half of y? Well, half of what number is 50? Half of 100. 100, and again, z is congruent, so it's 100. And one way to check your work is you're going to add them all up. 100 plus 100 plus 160. Does that equal 360? Yes, it does. Then we move on to our next problem. Find the value of x. So x is in these expressions for these angles. What does this have to do with inscribed angles? What does it have to do with the properties that we learned yesterday? Well, you should notice that this segment right here is a diameter. And so the third property that we learned yesterday told us that, well, then this is a right angle. So if I want to solve for x, I can set up an expression using prior knowledge, what we know about triangles, that all of the angles add up to 180. So we're going to say 90 plus x plus 1, 2x plus 1, plus 2x minus 3 equals 180. Because those are the three angles in a triangle. So 2x plus 2x is 4x. 1 minus 3 is negative 2. And so 90 minus 2 is 88. And so we have 4x plus 88 equals 180. Next step, we're going to subtract 88 from both sides. And you get 4x equals 92. Last step, we divide by 4. 92 divided by 4 is 23. X equals 23. So on the back of our warm-up, we're no longer dealing with inscribed angles. We have a few, but we also have a few of these angles. This angle is outside, this angle is inside, but it's not inscribed. And so the first two problems deal with inscribed angles. In fact, number 1 is just like the last problem we did, where we have to find x given that we are given the diameter and that this inscribed angle is 90. So again, we're going to set up our problem where all the parts, we add them up and they equal 180. So 2x is this part right here plus 3x minus 5, this part right here, plus 90, the inscribed angle, equals 180. 2x plus 3x is 5x. 90 minus 5 is 85. So 5x plus 85 equals 180. Subtract 85 from both sides, and you get 5x equals 95. Divide by 5, and x equals 19. X equals 19. And then we move on to number 2, where we have another inscribed angle, angle x, and we have to find angle x. Well, we know that whatever angle x is, it's going to be half of this arc. This is what the theorem told us yesterday, but we don't know what that arc is. We have another instance where we have to find something that we haven't talked about yet, but I'm sure you would be able to conclude is, why did they tell us that these chords were congruent? Probably because their arcs are congruent. So if this arc right here is 95, this one is 95 as well. And so what is the last arc? Well, we have to add up 95 plus 95 to get 190. And then we're going to subtract 190 from 360. 170. So this angle is 170. Now I can set up my problem. The angle is half the intercepted arc, so half of 170. What is half of 170? Yep, it's, I believe, 85. X is 85 degrees. And I'm just going to check that with my calculator real quick. Great. So, we move on to our last two problems. Here, this one's different from the problems we did as homework and from the problems we did yesterday, in that they give us the angle. We're not trying to find the angle, we're trying to find arc measures. But what does our theorem say? Our theorem says that the angle equals 1/2 the sum of the arcs. Arc plus arc. So we're going to plug in our pieces into this equation or expression. The angle, what is it? Well, the angle formed between these two chords is 88 degrees. 88 degrees is half of the sum of the two arcs, the sum of x and 44. So how can I solve this? You can put it in insolve, that's an option, but we are going to solve by hand. First thing I'm going to do is get rid of the fraction. How do I do that? Multiply. Here, the fractions go away, and here 2 times 88 is 176. 176 equals x plus 44. Now we're going to subtract 44 from both sides. 132 equals x. We've solved for x. 132 degrees. Now we just have one more to do. This is the one where the angle is outside. So when the angle is outside, pretty sure this 15 degrees goes there. It does. When the angle is outside, x is no longer 1/2 the sum, but rather it's 1/2 the difference. So we can find x by taking the difference of the two arcs. We have this arc and we have this arc. Are we going to do 160 minus 15 or 15 minus 160? Well, if we want a positive difference, we need to do 160 minus 15. 160 minus 15 is 145. We have to figure out what is half of 145. Half of 145 is going to be 72.5. 72.5 degrees. All right. Make sure you get the worksheet from the sub and work on that, and then work on your final exam review. I will see y'all later. Bye.